Hey everyone, I'm Joshua Deemer, and welcome back to Lesson 11 of our Java Programming Tutorial series. Let's jump right into the lesson. Let's discuss in more detail how variables are stored in your computer's memory. When a variable is declared, it gets assigned a memory address to help the computer find where the memory is located. The data type it is assigned to helps the computer know how many bytes to allocate in the memory for it. When this variable is used, it is retrieved with the same memory address and decoded from binary to match the data type of the variable. A good way to understand this is through real housing addresses. When someone buys a home, they are assigned an address for that house. When we want to find that same person, we get their address, which shows their location no matter where you are in the world. However, memory addresses are more obscure than simply stating 1234 address drive. Memory addresses use a 4-byte hexadecimal number, also known as an integer, to store their location. Let's talk about value and reference types now in Java. So a value type is essentially any primitive data type, and what it does is you can understand it as copying the information into the variable. Okay, so we're copying 500 into the variable. So just how you have been understanding it, that's essentially how it works for a primitive data type. For a reference type, we use what we just learned with our memory addresses. What this does is it takes the memory address of I and stores it as the variable. It takes the memory address of our string builder and stores it in the variable. It takes our memory address of our car and stores it into the car variable. Okay? And we'll see why this is important with methods. So let's take a look at value types. So here I create an integer. I'll just rename it to A rather than that. So we set it equal to 5. Now remember, this essentially copies 5 into the variable, if you want to understand it that way. Then I made an update method, and we're passing in an integer, so I pass A in to value type. So then we set value type equal to 1. Then we print it. Okay? Then after this method is run, we print out A. So what you would assume happens here is we have A equals 5, right? Then it updates it to 1, it prints 1, then it prints 1 again because we updated A inside of our method here. But if we run this, you'll see it says 1, 5. That's because what we do with value types is it copies the data to here rather than passes the actual variable to here. Okay? So what this does is you're saying, all right, value type is now going to equal a copy of A. So that means value type is 5 now, and then we set value type to 1, which doesn't affect A at all since this is a copy. It's a clone. Okay? And so we print out 1 here, and so since A is unaffected, it doesn't become, but it stays at 5. Now what about with a reference type? So here I've created a car, okay? It allocates a new car, and all I have in car, we can get rid of this, is make, okay? So here I set the make to Toyota, and I pass car in to our update. Then I set the make to Honda in here. So if we follow like we were before, this would send a clone into here. Honda would be here. Then it would print Honda, completely unaffecting the normal car. And then it would print out Toyota here, right? But here you can see that it prints out Honda twice. That's because car is a reference type. What we do is we pass the reference or the memory address through our update method. And so what's actually appearing here is the actual car that is here. And so we are actually updating our car from our main method in our update method. Okay, so what we're doing here is we're making our car, we're setting its make to Toyota. Then we pass the memory address of our car into update, and it takes it here. Then we update it to Honda. So this updates the memory address car and its make to Honda, which affects this car as well. Then we print out the make, which is Honda, and then it comes back to here, and then it prints out Honda again, because again, we affected this. The reason that it does this is because, let's say, for example, you have make. Let's say you have all of these different variables. Now, this is not realistic, of course, but let's say you have all these different variables, and this one is 20 characters, which equals 20 bytes long, and all of these are 20 bytes long. It would be a lot of memory usage in order to pass all of those, 20 times 10? 200 bytes. So if you were to clone that, it would clone 200 bytes, and that's a lot. It's not a lot when it is simply... when it is simply an integer. An integer is just 4 bytes, right? When we pass the memory address, we're just passing an integer in, which is 4 bytes. So that's why it can save a ton of memory and performance with reference types doing that. Now, strings, they are technically reference types. However, because of their immutability, meaning they're not really changeable, when you make a new string, you literally make a new string every time. So if I do string plus equals world, you're making a new string there, just taking this string and adding it to it. It's what's known as immutable. It behaves more like a value type. So string is probably the only exception to this rule. If I press run, you'll see that we pass in string, and it is hello there, right? And so we change it to world, so it should print world, and it should print world here as well because it's a reference type, but it behaves more like a value type. And so it would be best to understand this as sending a copy of itself as well. It's one of those exceptions. While we have some spare time, let's go ahead and talk about some shortcuts we can do. For example, one of the shortcuts that we can do is the variable declaration and redeclaration shortcuts, such as if I type int x equals 0 and int y equals 0, and we'll just do int z equals 0. This is fine. I do actually prefer to keep it this way, but what you can do is you can also add a comma, and this will also initialize all 3 variables in one line if you prefer to do it that way. Reinitializing, if you do x equals 20, y equals 20, and z equals 20, right? Let's say they're all the same number like this. You can reinitialize all of them like this if you'd like, or you can say x equals y equals z equals 20. And this will reinitialize all of them in one line to 20. So if I say system.out.println here, x plus comma plus y plus comma plus z, and run it, you'll see it says 20, 20, 20. Okay? Now, this is fine. I don't often do this, but you will see me do it occasionally if you watch me code. I don't think I've ever done this. I like to have them on individual lines. But if you prefer to do it this way and to minify your code, feel free. Let's go ahead and talk about some shortcuts I actually use. So here I have 2 variables, x and y, which are 5 and 10 respectively. Then I have this if, else chain, printing out exited, then a while loop, which continues until x is greater than y, or greater than or equal to y. Then we print the x and y. And then we have a for loop, which runs 5 times, prints out I, and then we say done. And I did already run it, and it prints is less than, which is true, it says exited here, and then we have x is 10 and y is 10 because we went through this while loop. And then we went 0, 1, 2, 3, 4 because I did print rather than print line. Then I added a new line so that it would be on a new line. And then I said done. Okay. Now the shortcut you can do is if your if statement, or if your else if or else statement, while loop or for loop is only one line long, you can completely do away with your curly braces. If it's more than one line long, so let's say for example here we say x equals 10 then, okay? And I get rid of this, there's no error. However, the way that it's interpreting it is like this, to where this is no longer part of the else statement. If I run this, save it, you'll see it'll say is equal to, even though we intend it to be part of the else statement. It's because you can only have one line in your else statement, or if you remove these curly braces. So if you have more than one line, keep those curly braces there. But we don't. So, what in the world? Okay, so I can remove them. Okay, I can remove them here too. There's no errors and it runs exactly as it did before. It's just a nice little shortcut. You can do this with your while, and you can do this with your for. If I run this, it still runs just as it did before. Keep in mind, once again, if you have more than one line, then make sure that you are using your curly braces. You can also nest these if you want. If x minus 1 equals y, or x equals y minus 1, that's probably more appropriate, then you can do this, right? It'll just be one line, but that's fine. If you want to do that, you can. But that's how you can use your shortcuts with these kinds of statements. The final shortcut we'll go over is with arrays. Now, you've seen me initialize arrays like this, like with all their starting values, 0 to 5, because I made an array of 5 items. And you've seen me initialize them like this. These two produce the same result. Let's get rid of this. If I were to print this out and did one or the other, they would all say 10, 20, 30, 40, 50. Okay? This one just uses calculations to determine that, right? But there's a shortcut that we can do as well here. Now, I'm going to keep these here so that you know that there's nothing wrong. But if we wanted to, we can actually initialize all 5 of these within the declaration. Okay, within the initialization. If I get rid of this 5 and add curly braces here, I can say 10, 20, 30, 40, 50, and it will know that this is an array of 5 items because I put 5 items in here. Okay? It'll assume that for us. It's not going to make an array of 6 items because I don't have 6 items in here. If I remove the 50, it'll make an array of 4 items. It'll automatically do that for us. Okay? And so this does the same exact thing as this and this, just in the same line. So if you wanted to do that, feel free. There's also completely getting rid of this new int and just simply having these curly braces 10, 20, 30, 40, 50. Because it'll assume, okay, you're making an integer array, and so we're going to assume this is a new integer array of 5 items with 10, 20, 30, 40, and 50. If I go ahead and say for int I equals 0, I is less than array.length, so getting the length of the array. Then we say system.out.println array of I. So we're getting each item of the array with this. And in between, I'm going to say print line, just so you guys can also see here the length of the array. Array length. plus. And then here we can say index, index number plus I plus this. Now if I run this, you'll see that it did exactly as I said it would. Okay, if we say new int array here and run it, it does exactly the same thing. So this is a nice shortcut you can do for initializing arrays. While we still have some time, let's go ahead and cover StringBuilder. So you've seen me use StringBuilder a couple times, right? And it does exactly what it says. It builds a string. Inside these parentheses, you can have a string that would be your starting string. So if I said hello here, all right, then underneath we can say builder dot append, and we can append whatever we want to the end of what this initial string is. Of course, we could have it blank and have it start, right? But if we append, we can say something along the lines of space. Then we can say builder.append world. No space, because we already did that. Then if I say string, I'll just call it string, equals builder.toString. This will convert our data into a string. And so if we say system.out.println string, this will say hello world, just as if we would do it like this, right? Or just as if we would do it like this, right? However, a string builder is a lot more optimized than just concatenating strings, okay? You'll want to use it when you're concatenating a ton of strings together. And it is not, so you guys don't know what this means yet, but it's not thread safe. It is asynchronous. So if you want to be thread safe, then you would use a StringBuffer. This is also a possibility. It does pretty much the same thing. It's a little bit slower, but it is safer to use. I'll just say that for now while you guys still don't really know exactly what that means. These are important to know if you want to take a certification exam for Java. They have a lot of StringBuilder and StringBuffer questions in the test and in practice tests. That's the end of this episode. Next episode, we will be covering constructors in Java. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!